Hello everybody, welcome to Mr. Metric. Today we're going to talk about the following building. It is the Galleria in Gwanggyo, South Korea, designed by OMA. And it's a shopping mall, which basically consists of a cube with a very cool facade wrapped around the building. And today the main focus is also about how to create this facade, because we can just treat the volume itself as a box. So that will be the focus of today's scripts, and let me go with you through the different parameters that we have. So we have our base curve. So basically at the moment this base curve is projected on the box. I will show you in a minute how that actually works. So in order to show you the first parameters, so the first parameter is the box dimension, right? So lower this value creates a smaller box. So now let's just put it at 70. The second one is actually the resolution of the box, because we are mapping an image on top of the facade. And if we, let's say, put this one to 1000, it simply lowers the resolution of it. I like the value of 3000 over here. So the facade curve, right? So we can do this with it and it will change it completely. We can play around with all these vectors, right? It will like move. So maybe we keep it as it was. This one we can, I don't know, put to 8. It creates a very big one. We can also make it very small. But with this one, we can completely change everything. So this applies for the upper curve, but also for the down curve. So let's say put this to 2, it also really change everything. So with this one, we can actually play around with where do we want it to happen. So it's at 0.56, but we can also put this at 8.8. Actually, we can just play around with this number and this will play anywhere on the facade. Let's put it at 0.56. I like that number. Basically, this is the depth of the extrusion. So if you put this a lower number, it extrudes less. The width is simply the width of the extrusion. So the lower the number, the lower the extrusion. Put it to 8. Let's put it to 12 or 13. So we have like the load length, so we can play around with this number. That happens more on this side over here. So here you can see how much it goes inwards. So we need to balance it a little bit. And also with like the edge strength. So there we can really change how it works. I like this one. Shave seat, we can really turn it around if we want. Vertical, horizontal domain. Yeah. We have the load length to the outside. Deformation seat. Now, once we're happy, we turn this one to false. And we turn on this guy. And let's say we have an extra curve. So let's refresh this. And let's put an extra curve over here. Say maybe this one now also belongs to curve. Change object layer. Then it will be there as well. Then again, we can play around with this one, where it should place. Maybe let's do that over there. Okay, let's go. So the starting documents that we have are 3 different things. The first thing is that we need to draw like 4 curves in Rhino, because they resemble the different elevation that it has, north, east, south, and west. The second thing that we need to draw is the curves, because these curves basically will be the guides for the glazing system that's going to be wrapped around the building. As you can see, the glazing system is going over multiple facades at once. Actually, just like you see over here, you see like it's going like this. And then again, it comes back at the top to this facade elevation. And the last thing that we need is the elevation itself, because we're gonna map this on the building in a certain resolution. So those are the 3 basic starting documents or geometry, however you call it. Okay, so this tutorial is gonna be divided into 3 parts. Now we talk about like the first part, and for the first part, these are the parameters that we need. And so here are the 3 geometries that I talked about. So we have the base curve, the facade frames, and the bitmap image, which was this guy. We are referencing the layer instead of the geometry, so that makes it easier, especially if you're gonna draw like a new curve. It automatically gets referenced, and then it brings it into the Grasshopper. And we have 3 parameters. And maybe starting with the first one, the box domain. Because we're gonna start with making the box. Here's the box. And the box domain, it's 70. We're gonna use the center domain. This is a component I use a lot. And actually, we're gonna put all these in. And this will create our box. So basically, here we have our box. So let's make it into ISO. This is our box. This is our starting one. So let's also make a remote sender and call this box, because we need this quite a lot throughout the script. And we're also gonna make one for the facade, because here it divides it into top, bottom, and side. So here we're gonna call one and call this one facade. Yes, and we use Telepathy, by the way, just like I always use in my scripts. Okay, this is the first part. The second part is that we need to bring the facade frames, because it can be that they are not sorted in the right way. So what I mean, this one, this is exactly what I mean. Right, so this is 1, this is 2, this is 3, and this is 4. No, that can also make sense, but I wanted to just start over here. And since we working, let's say this is the plane that we have, so green is the Y and red is the X. So we're just gonna use it once. So we're gonna sort these panels in the X direction. So we're gonna bring in an area, because that gives us the center points. And we're gonna put sort points. Yeah, and this does it automatically, first by X, then by Y, then by Z. So then it gives me a different order. Yes. And then we're gonna use those indexes to change the order of it, because now, so it also says that like the second index is now the first one, the first index is the second one, and so on. And now you will see that it goes from left to right. Perfect. Okay, so this one, we're also gonna put a remote sender here, and we call this one projected facade panels. So here we have like 3 outputs that we need quite a lot throughout the script. Okay, also to help ourselves a bit, for easy visualization purposes, we're gonna use the box, and we're gonna visualize this. So this is the box. We're gonna do brep edge, and we're gonna bring all those. So basically we are exploding the box and getting like the curves out. Let's also hide the panel, the plane. And this one, we're gonna give it a color, and we're gonna give it the color black. Perfect. What we can also do is, which we need a bit more later, but we're gonna make this box, and the bottom and the top, we're gonna make it white. But that's more for later use. Yeah, so we're gonna hide this one. So these black lines, they're easy for navigation, because you can quickly see like where is what. Okay, the next part is we're gonna cut the base curve. And we're gonna cut the base curve. Let's see, where's the base curve? We're gonna cut the base curve based on the facade panelization, because based on the elevations. And once we have them cut, we're gonna project them on our cube. So that's the step that we're gonna do now. So first we're gonna graph the base curve, because we have 2 curves, 1 and 2. And we want to know where they intersect with the elevation panels. So they intersect at these points, yeah. Then I want to shift path because my input is 2 different branches, and I also want to bring it back to 2 different branches. Yeah, because a branch for every curve. And now we see like all the different intersection points. But sometimes some values are double, for example here, because it cuts like this facade panel, elevation panel, but it also cuts this elevation panel. So what we can do here is we just create the unique items. Yeah. Once we have that done, now we're going to use shatter. Shatter is a component where we can cut something with. And we want to cut this curve based on these parameters. And once we have that done, we're going to flatten this list. And now every curve is cut based on the elevation panels, which is correct. The thing is now, this is one big list, but we want to put them in branches accordingly to which elevation they fall, right? So we want to put this into 4 different branches. So for sure, then we need a curl pattern because we need to manipulate it somehow. But we need to check in which elevation panel they fall. So what we're going to do is we're going to check the midpoint of these curves. So these are the midpoints of the different curves. And we're going to check in which elevation they belong. There's a point in curve. These are my points. The curves are here. Now, since this is a flattened list, I'm going to graph the facade panels for every elevation panel 1. And it also says like it gets a value of 2 as soon as it's inside a curve. Right? So we're going to check all these values and we're going to check whether they are equal to 2. And if that is the case, it gets a true. Otherwise, it's a false. We're going to bring this list in here and let's see how that worked out. Yeah, perfect. So this is the north, east, south, and west. Perfect. So the last thing what we're going to do now is we're going to project them on our curve here. On our volume. So we're going to do project mapping. Where is map to surface? Is it map to surface? I think it's map to surface. Yeah. And our source target, so we need this one because these are facade panels. This one is the target. No, this is the source. And it should then go to facade. Yeah, it should go to facade. But since this is grafted per elevation, we need to do that the same for these 2. Because we need to have an equal amount of data branches. So let's see, this is the source and this is the target. And it works perfectly. And so these now are like mapped. And what we can do is we can go to the curves and we can actually change them. And you will also see that they will be changed on, yeah, you see it happening there. Or let's say we take this one, we put it a bit higher. You see it changing. So now we have a direct link to whatever place here is now projected on top of our cube. Perfect. So let's get back to our view. Let's hide all this. This is the curve we're working with. And let's call this projected base curve. Yeah. But let's say we call this projected base curve. Yes. Next step is that we are gonna mesh the facade as we have it over here. Because we want to bring this mesh facade, we want to bring it in here to read the color from the image. So that's the next step that we're gonna do. Yeah, so let's head back to ISO. So what we're gonna do, so we have our projected facade panels, right? So we can already graph them because we have like 4 panels. We also have our facade. And we need now one of the parameters, which is the meshed target count, which is at 3000 at the moment. Let's not make it much higher because the higher the number, the slower the computational time gets. But what we're gonna do, so this is our facade and we're gonna quad remesh this facade. And quad remesh, so we're gonna mesh it, just so it's clear for you, we're gonna mesh this facade. So the settings we're gonna do, we're gonna go into quad remesh settings. That gives everything a bit more space. So the target count is this guy. And we want to put the settings in here. So one thing that we like to do is we like to make it triangulate. We can keep it in cubes, but I think triangulates now just makes it a bit more interesting, which basically makes triangles of it. And then we have 4 surfaces. We're gonna disjoint this mesh to bring it per elevation. It gives me 4 branches, correct? And also let's make an output which is called meshed facade, because we need this guy later. So now we're gonna do a rectangle mapping. So here we did like map the surface, but now rectangle mapping. So this is our, we also have our facade, and this is the quad remesh, but we need to graph this. And we're gonna make a plane surface because we want to make sure that is the plane in the middle. It is, yeah. Let's read the dimensions of the surface. The U, the V, so basically the X and the Y. We're gonna center domain, and we're gonna rebuild the surface. This is just as a sort of quality check to know that everything is going in the right way. So this is my, again, so this is the source and this is the target. So this is the source. We're gonna do something similar actually over here. So let's just copy this code. Yeah. And actually we're gonna do something similar here. And I think let's bring this to like target. Is it doing that? Almost. This is not going well. Maybe we need to start with a plane. So I think because we have a curve over here, what we should do is make this a surface and then bring it in there. Ah yeah, that's the trick. Yeah. Because like if it is a curve, once it is a surface, it recognizes to put the plane in the middle. But what we need to check at the moment is, let's put projected. So we can check below here. Yeah, so this is the corner. Yeah, so 2 times the right direction and 4 times left direction. Is that correct with this one? Because we don't want it to be like upside down. 2 times right and 4 times left. Yeah, so it's going well at the moment. Very happy with this because this mesh facade is now on here. Let's hide everything actually, but let's just focus on the curve. Now we have our rectangle mapping. Okay, and we're gonna call this projected mesh facade. Projected meshed facade. And let's bring the colors in. Okay, first thing we're gonna do is we're gonna do Ctrl M, because I don't want to see the preview mesh at all times. So do know it's Ctrl M. We need this guy, the projected mesh facade. And we also need like the bitmap image, right? And the bitmap image is this image. So those 2 we need at the moment. So let's first flatten this guy. Mesh explode and again flatten it. Yes, so we have like 2400 indeed. So let's zoom a little bit out here. Yeah, maybe also hide the image for now. Yeah, so our bitmap image. So first we need to get the picture source, because then Grasshopper can read the picture source. And then we need sample bitmap. Yeah, so this is the path of the source. Okay. Because here we just have like 1 and 2. I don't know where the other one is, but yeah. So we can do that a few times, so we have a lot of triangles. Yeah, okay. And for all those triangles, so let's work with area. Perfect. Okay, let's bring the area and let's deconstruct those. So we're gonna deconstruct them. Let's turn off Ctrl M. Yeah, so what we're gonna do is we're gonna check for all these points on which color they fall. Right, so here it's white, here it's gray, here's white, and so on and so on. Here it's brown. And it's gonna map that color on the mesh face. That's what we're doing at the moment. But before we can do that, we need to remap all these numbers because we need to bring it back to a value that goes from 0 to 1. So we're gonna remap them. With bounds, we know like bounds is the minimum and the maximum of the value. And the target, the T for target, is 0 to 1, of course. We're gonna construct a new point. The point is gonna be an X and a Y. Yeah. We're gonna color the mesh, then that we can do that is also a property of the mesh, right? It's what we can do. Coordinates, oh yeah, we need the coordinates. Yeah, so the coordinates, they are here. Perfect, yeah. Then, so we get 24,000 colors, right? So we're gonna graft it. And those colors we're gonna give to this. And let's also graft these panels all again. And that's gonna go to the color. Yeah, so as you see what we did, so this is our new image basically. So this is the existing image. And this is like the image, the colors of that projected on our mesh. If you play around with the target count, it's basically the resolution of that mesh. So if you put this to 2000, it's gonna be more pixelated, or the pixels are gonna be bigger. I like 3000, you can do more, it's more accurate, but then again, it also is more computational time. So this is the first step, but now we need to map all this. So let's go to our ISO. And why do we don't see our ISO? I want to see it. Yeah. Yeah, so our ISO viewer, now we're gonna project these colors. So we're gonna do mapping again. Rectangle mapping. Yeah, and we're gonna put those. We're gonna use something similar as here, right? So this is our mapping. The thing was, these were curves. Yeah, so we need to make surfaces of those and then it will work out fine. This is my facade, correct. Yeah, so this is my target and this is my source. And it's not doing it good at the moment. That is interesting. Ah yeah, okay, so we need to flatten these curves first. Let's deactivate this. So we need to flatten them. And we need them back to 4 branches basically. So, oh yeah, we can take this one. So I'm gonna use this mesh explode. You can also see the computer is a bit slower now. It's quite heavy operation for the computer. We're gonna unflatten, right? Because these, and we're gonna unflatten them based on this, and this brings it back into the data structure that it was. And so it gives it back into like 4 branches. And now let's put it in here. And now let's unlock. No, let's enable this guy again. And it works out perfectly. So like now we have our new surface. So what I'm gonna do now, I'm gonna put this mesh in here. And we're gonna play around with this mesh later. Let's just call this visual mesh facade. Perfect. And then what I want to do is I want to hide this whole part here because it takes a lot of computational power. Let's hide it. Perfect. And we're gonna go back to this guy later.